the MTDCNC Podcast, sponsored by Langley Alloys, unique metals for demanding applications, providing first-class performance and an international service.
Welcome to another episode of the MTDCNC Podcast. Today I'm with two gentlemen from optimised UK. Probably familiar faces if you're watching this, and if you're listening, I'm sure you will have heard them speak before. So Adrian and Ken, welcome to the MTDCNC Podcast. Good to see you both. 25 years, optimised UK, Adrian. That's gone quick, isn't it?
It has gone quick, yeah. And as with most people in that side optimised, they're here for those 25 years. A lot of them, our employees, are here a long time.
And it's fair to say that the CAD and CAM has evolved so much in the past 25 years. So that's the sort of things that we're going to talk about on this podcast, as well as where the future's going. You know, we'll talk a little bit about your virtual machine product, how popular that is. I remember when we started talking about that was it maybe 3 or 4 years ago? So that's come on a long way. Automation is a big topic as well. So we'll cover those things during this podcast. When did you start with the business then, Adrian? Give us a little bit of background about yourself and what this journey's been like over the 25 years.
Well, I was actually a user of the software before I actually joined optimised. And I was actually number 2 in the UK. So somebody was Clifford Ashman, the name from the past, was started the company, and he took me on as an application engineer at the time.
I remember Clifford. Good grief! I mean, when did he stop working for?
It's probably 3 or 4 years after I started, so maybe 20 years ago, something like that.
But you had a bit of a dealer network, didn't you, at that time, and then that transitioned?
That's right. I thought I was really employed to help or look after the dealer network that we have. We have 14 dealers at the time, and they were selling a variety of different products, hyperMILL being one of them. And I was employed really to help assist them and technically with the product.
And I suppose it was always better to be going direct in the end. Would you agree that was always a path that the business was looking to probably?
Yeah. So at that time, we just started our journey into the 5-axis environment, and we were doing something a little bit unique and clever with collision avoidance technology, which is to a certain degree still have a little bit of a USP for what we do. And going direct enabled us to really be more competitive and learn those skills needed to really offer the best solutions to our customers.
I mean, Ken, if Adrian was number 2 in the business, which number were you?
It wasn't number 3. It may be 5 or 6. I don't know exactly. We'd have to check the records.
But that was back in 2002 as well, or
no? So I was working with one of the resellers. I started there in 2002. And then in 2005, when optimised UK wanted to go direct, they asked me to join them. And nearly 20 years later, here I am today.
Yeah. Now, I want to imagine there's people listening or watching this that it's the first time they've stumbled across, CAM or whatever it might be, the name. Ken, best describe what optimised does in a brief sentence or two, as well as hyperMILL, for those that don't and aren't aware of what you have and do.
Yeah, so optimised is the company, and our product is hyperMILL. So hyperMILL is a CAD/CAM system that goes from simple 2.5D milling, 5-axis simultaneous, mill turn, probing, electrodes. We cover pretty much everything that's in the machine shop. And really where I would say where we stand in the marketplace is we are all about innovation.
And that word innovation is, if you look at the last 25 years, and I'd be interested in your take on this, Adrian, how much has this marketplace changed? I mean, what can you do a lot more now that you couldn't do then? Because although 20 years sounds like or 25 years sounds like a long time, it's not that long. But this area of manufacturing has changed so much, hasn't it?
If you look at, for example, 5-axis, which is, we in the past we made a little bit of a name for ourselves in that environment, as I just said, that it was very specialized in those days, and very few companies or machine tools were able to really do 5-axis well. And there was a lot of learning in the early days. These machines were not really capable of doing 5-axis well. And so we were both on a journey, the machines, the controllers, the software to offer a nice solution. So that was a lot of learning in the early days, and this is now commonplace now. So most people will buy a machine tool, and it's like hyperMILL, and it's quite an easy entry into cutting very complex parts, which it wasn't in that back in the day. It's very experimental. It's a lot of learning. You have to be highly qualified to get good results. And now it's like 3-axis was 20 years ago.
Yeah, I mean, I suppose the biggest thing is trying to get someone, these barriers to entry. How easy is it for me to use? How difficult is it going to be for me to get to grips with? How much am I going to save? How much is it going to improve my processes? Are those the sort of battles you would have faced over the last 25 years, Ken, when, obviously now in the sales director role, but throughout that journey, getting people to buy into the fact that this is going to be the way forward for them and make them more productive?
Yeah, I mean, it's always a challenge. That's the nature of what we do, but we love to show people what hyperMILL can do. So that's where it's got to start with. They either come to us, or maybe we're in contact with them because they've hit a bottleneck. There's something it can't do. They might have hit the ceiling of their existing system, and there's parts are becoming more complex. And it always starts off by we give them a demo. We like to take, right, give us your tricky parts. Let's show you what hyperMILL can do with it. And more often than not, we're doing what they either can't do or takes them a long time to do within minutes. And it's at that point people really get, right, I can see the value in hyperMILL, and it's clear it's going to improve my processes.
I mean, what's a classic part? When you're presented with a part, which are the ones you look at and go, that's a winner for everybody in this? I mean, you must see lots of parts and think we can make savings there, but then you see one and you go, that is exactly where we need to be with our CAM system.
It's surprisingly, we are known for 5-axis, but surprisingly, it's sometimes what we would maybe consider the more straightforward things where people are actually having difficulties, or it's taking them a long time. And we've got really, really nice technology. So we've got our own, the CAD engine is our own. And we're actually developing CAD tools that are making things easier for the CAM programmer. For example, when we select a surface to say that is my machining surface that I want to create a toolpath on, we can automatically extend those surfaces, because normally you want to do that because you don't want the tool to run off the edge. And people see that and they go, wow, I mean, in my other system, I would have to create an edge, pick a boundary, manually extend those surfaces, then I would have to pick them. And we've done it within a mouse click, and we're on to the next thing. And sometimes it's those real simple, straightforward things where people go, I mean, clearly, you've saved me minutes already, and that's just on something simple. So there are often more complex 5-axis challenges, pockets with undercuts. Really, I'm just struggling to get a 5-axis toolpath in there. And those are things where we can, do a very good job or very quickly. But it's sometimes just those things where people think that's the way it has to be. But when they see hyperMILL, they realise, well, actually, you've just made that process 10 times better.
And do you find, though, that, I mean, there's a lot of machine tools out there now that are advancing their own control systems and their interfaces to try and achieve potentially some of the things that we talk about in this environment. And they might even claim that they can, but how far ahead do you think that the hyperMILL software is compared to, let's say, the next best control system on the market for simplifying programming?
It's a good question. Of course, it's a slightly loaded question, but when you talk about, we are partners with all control systems. But if it comes down to, if you want to get the job done very quickly, you use offline CAM system like hyperMILL. I mean, you can do a lot of things on controls now, but if you really want to get the best performance out of your machine tool, I mean, simply programming on the machine tool when it's running is quite difficult anyway. So having a hyperMILL in the office or beside the machine, which you can you can focus on whilst the machine is running is a definite benefit. But we offer so much more than possibly a controller could possibly even do. Having access to all the CAD data, all the stock data means that we're intelligently trimming back the toolpath. So your toolpaths are not only nice for the machine tool, but also they're the most optimized thing you can have, and so your cycle time is a lot lower than it can be. So yes, you can make a toolpath on the control, but our toolpath will be trimmed right to the stock. It would be the exact toolpath, and it would end up being quicker and nicer on the machine.
And collision avoidance and things like that is, it's a key driver to a lot of companies as well. And virtual machine was something that I mentioned at the start of this podcast that we were going to talk about today. Adrian, what is that? Okay,
well, it has really three areas. So if you talk about the first area, which is it's a integration of really simulation and post processing. So it's not a separate tools. And so what happens is, what you see is what you get. So if you look at the simulation, you are actually getting that result on the machine tool. So there's no difference between the NC file and the simulation. Virtual machine is actually reading, it's actually utilizing the NC code and giving you trust to really what you're getting as your NC file is what's happening on the machine tool.
And is this where, when we talk about complex parts and things like that, Ken, when you're talking about solving people's issues on manufacturing those, is that where this fits perfectly as well then? Because it eradicates any of those risks that people would have in their minds and concerns about when they press that button, they're going to get a finished part.
Yeah, definitely. I mean, this is where the optimization as well with virtual machine comes in. So, as Adrian said, so it's NC simulation, which is simulating an NC file is not revolutionary. There's other things that do it. But what makes virtual machine stand out is there's an optimization module where we optimize that NC file as part of that process. So NC simulation could say there's a problem. It might be the machine tool's gone out of limits. Whereas the optimizer can say, well, actually, I can find a solution by modifying the C-axis of the machine, and it's solving it. So NC simulation tells you there's a problem, but virtual machine is solving them. So when you actually run the simulation, it's all fine. You're just verifying everything else, and it's all good. So that it's sometimes those complex things, or it's just solving it without having any user interaction, and that could save you quite a considerable length of time when you're having to go back to the CAM system if you're not using any optimization.
We've done some pieces off camera today with both of you about how dominant OpenMind and hyperMILL is in the motorsport arena, but of course aerospace is, it's huge here, not just in the UK but around the world. Adrian, this is a big area where you want to begin to penetrate more, isn't it? And why do you feel your product is perfect position, is positioned perfectly to be able to do that?
I think it's because certainly in the newer build programs, the parts are getting more complex. This is exactly what we saw in motorsport 25 years ago. So a small story in the past, you used to build parts by taking a block or a billet of material and you used to cut sections away from it until you end up with a finished part. Nowadays, because CAD is so much more powerful, you'd add a feature and then add thickness to it. So the parts become really, based around weight again, and the minimal amount of material you have in the parts. They were doing that in motorsport a long time ago, and they're doing it now in aerospace. Weight is a very important topic, and so they're making the parts getting more complex, getting larger, and the materials they're using are also challenging. So some of these exotic materials need different cutting strategies than were possible before. So it's a combination of parts getting more complex, materials getting more difficult, tooling strategies, machine tools, everything's coming together. And so in the end, you want to be producing complex parts quickly, efficiently, and as cheap as possible. Really.
Yeah, I mean, with the competitiveness of that market, of course, everybody's looking for the quality part, but keeping their costs down. So some of the points you talk about the different materials, the different strategies, would hyperMILL guide a user? Would it help create the perfect toolpath for that material matched with the right cutting tool and strategies?
Yeah,
is that really
absolutely? Data is really becoming key and important. So the way you bring data into hyperMILL, we interface with a lot of different tooling providers, pulling in their data just to get cutting information in. Matching it with the perfect type of toolpath to give you a strategy that not only gives you a nice quality result, but is good on tool wear. It's all important. It's all important things, and certainly with hyperMILL, the breadth of different strategies and options we do have to cater for this means that you can achieve a really quality result.
And with the aerospace sector, Ken, with you and your guys being out on a daily basis talking to subcontract manufacturers, top tier companies that are making parts like this, do you see this as a marketplace? Do you perfectly see it aligned with everything that hyperMILL can do?
Yeah, 100%. As Adrian said, the parts are becoming more complex. Everyone is looking for efficiency. We want to make parts cheaper. You can keep throwing time at things, but what you really want to strip out time, and you've got to look at the tools that you're using. So if you're pushing the buttons as quick as you can, and the tools are that you've got the tools running at 100%, really that would be the next step where you've got to start looking at the CAD CAM you're using. Can you get a more optimized process? And I think from what we've seen in motorsport, where they were using these systems that are now being used in aerospace, those have all been pretty much replaced. And I think that's the next step for hyperMILL.
And have you got any situations at the moment where you're working within the aerospace sector where you've got companies that have adopted, the hyperMILL software, that you're able to go, actually, yeah, we've seen this is real now. This is happening.
Yeah, definitely. We've got so many case studies where we've shown real productivity gains. It is a slower moving industry, aerospace, compared to motorsport.
Why do you think that is? Regulation?
A bit of regulation, but then again, there's a race. There's 24 races a year in motorsport. You've got to hit those deadlines, whereas a build program on an aeroplane is several years, and there's probably a little bit more regulation that you've got to get through that red tape as well.
Because you said something quite pertinent, Adrian. You were talking about the strategies advancing with the cutting tools and the machine tools, and that's almost like a self-learning thing, which brings me on to sort of the topic of AI, really, because it is a hot topic. I mean, is this something that it's learning all the time as you're doing these things, or is that the next step for you guys? Is that where you're going to be heading? Because everyone's talking about this at the moment, aren't they?
Yeah, I mean, AI is somehow a buzzword topic. I mean, but what does that really mean? What does that really mean? And I think it's interesting to to dive down into the details, not just put a flag on it's got AI in something. We've had automation for more than 20 years, and our automation solution now is really sophisticated. But would you call it AI? Some people would call it AI, but it's not what we would do, what we would call AI. So we have a huge automation solutions behind the base hyperMILL product. You can really make advancements in getting things programmed a lot quicker. So you can start with automation, but is that really AI? AI probably not. It's AI to me it means you really have to train, and you have to collect data from past processes, or it has to learn, and that's the challenge in AI, is really collecting data.
And is this something that hyperMILL is looking at, and that people can expect to see brought into the product range within the next year, 2 years, or however long it might be? Absolutely. So if anybody's, I expect most people have used
things like ChatGPT or something. Whereas it's basically just taken all the data off the internet and it's learned from something, learned from all that big data set. But how do you do that in CAM? Where does there's not this data is not living on the internet. It's living in people's servers inside their businesses, and so that's where we see the next challenge is to reuse that data that's inside businesses to actually learn from that data, because the AI needs to learn. It's not going to find just by magically going on the internet, going to find the answers. It needs data, and that data is locked away in people's servers for, if they've had CAD/CAM solutions for lots of years, and certainly our customers have got tens, hundreds of thousands of parts locked in on their servers. If we can reuse that data, learn from it, then you would say, oh yeah, 10 years ago we did that part and it took X amount of time. And so from simple quoting purposes, you could reuse that information. You say, I did that part 10 years ago. I can't remember what it was called. I don't even know what customer it was. I just remember something. AI will find that for you. It will find similar looking parts. So you have a new part you're quoting on, and it will look in your library for existing parts. So that's one area AI can help. But there's so many other areas. Help, for example, is we have a really comprehensive help desk. But if you empower people to have that knowledge at their fingertips, so all the knowledge that we have in our databases, or our support cases, all the things in people's minds, all those emails that we've written, if you can get AI to really look through that data, then if someone is hitting the similar problem, they can type something. It's not just like looking up a manual or something in a manual. It's really looking at a huge data set and
it's almost real life situations.
Yeah. So they can do a little bit of their own homework without having to call into the help desk and speak to someone.
And Ken, we're going to wrap this up shortly, but I want to, from your perspective, the next 2 or 3 years ahead, where do you see hyperMILL being? Where do you see users benefiting further from your product? If you had to look 2 years down the line, I know nobody's got this magic crystal ball, but from your last 25 years experience, what's it looking like, this field, this playing field?
From an open mind perspective and hyperMILL, the future looks fantastic. There's, as Adrian talked about with the automation and AI, that really is an area that's going to start to gain a lot of traction over the next years. And there's never a time, I don't think I've ever found a time in open mind when there's been so many new things on the horizon. Some things we can't unfortunately talk about right now today, but certainly from what I've already seen, there's some really exciting things coming out, and it is about innovation, as I said at the start, but all of these things are there to make people more productive.
And of course, with this 25-year celebration, Adrian, what is the company going to be doing? What are you going to be treating your staff to?
Well, sometimes it is so busy. It is so busy that we don't take time to stop and actually celebrate our wins, celebrate the things we have done in the past. So we will be doing some sort of summer party as soon as everybody comes back from their holidays. We will do something together, team after the summer. Good
stuff. Well, I think we've been working together with yourselves maybe for a decade or so now, probably. So we've seen a lot of this journey and seen certainly the growth in your user base, and I'm not saying this flippantly, but it kind of does surprise me when I see the amount of companies that are now buying into what is, what you guys would say is one of the best CAM solutions on the market. I mean, you are having a real impact, and as I say, even if overseas, I'm seeing your product. So it'll be interesting to see how the next couple of years unfolds. Thank you very much for your input today, and also from an audience's perspective to learn more about what the future could hold, but also to know where your origins were and where it all started. So thanks very much for joining me, guys. And that's it for another MTDCNC podcast. Thanks for joining this episode. Of course, we'd love you to keep following our channels, like, comment and subscribe to wherever you are listening to this. Thank you very much, gents.
Thank you for listening to this episode of the MTDCNC Podcast, sponsored by Langley Alloys, specialists in a wide range of exotic materials for any application for all your engineering needs.